We hear a lot about the amazing potential of artificial intelligence, particularly these large language models. But today, instead of just speculating about the future, we're diving straight into the present. We're looking at a new study that's trying to answer a really fundamental question. How well can AI agents actually perform real-world work tasks today?
Exactly. The buzz around LLMs has been, well, incredible, and it's easy to get lost in the hype.
Right.
What this new research offers is a really rigorous look at their practical capabilities in professional settings. It's moving beyond those theoretical possibilities to, concrete performance.
And the tool they've created to do this is fascinating. It's called TheAgentCompany.
Yeah.
Essentially, a fully simulated software startup, complete with its own internal systems and even AI-driven colleagues. The whole setup is designed to see how effectively AI agents can handle the kinds of tasks that, well, people like us do every day at work.
The motivation behind the TheAgentCompany benchmark is really key here. While LLMs have advanced so rapidly, we haven't really had a consistent, objective way to evaluate them on, realistic professional tasks.
Makes sense.
As the research points out, there's this significant debate about how much jobs might be automated. You've got some predicting major changes, others questioning if these LLMs can truly reason and generalize to new situations.
So this benchmark aims to provide some actual data. Cut through the noise a bit.
Precisely. To help us understand the current reality, not just the potential.
Okay. Simulated software startup sounds pretty in-depth. Can you give us a clearer picture of what this environment actually looks like? Break it down a bit.
Yeah, sure. It's a very detailed and, importantly, reproducible environment designed to mimic a small tech company. They've built in the different roles you'd expect, like a CTO, project managers, software engineers, even HR and finance.
Okay.
But what's really clever is how they've simulated the digital workspace itself.
So it's not just giving an AI a problem and seeing if you can solve it in a vacuum, right?
It's
more integrated.
Exactly. The environment has several key parts that are meant to reflect a real online work environment. First, there's a local workspace.
Okay.
Think of it like simulating a work computer. It's got a browser, a code editor, and a Linux command line. Standard stuff.
Right.
Then they have an intranet. This is built using open source alternatives to popular business software.
Oh, interesting. Like what?
So think GitLab for managing code and wikis.
Yep, familiar with that.
OwnCloud for sharing files. Plane for keeping track of tasks. That's kind of like a lightweight project management tool.
Okay.
And Rocket Chat for internal team communication, similar to Slack or Teams.
Wow. Okay. That's impressive. They've really got the internal software stack covered.
Yeah.
And you mentioned AI colleagues. How do they fit into this picture?
Yeah, that's another layer. They've used a platform called Zootopia to create these AI-powered simulated coworkers.
So not just chatbots.
No, they're more fleshed out. They have detailed profiles outlining their names, their roles within the agent company, their responsibilities, even which Rocket Chat channels they hang out in.
Wow.
Interestingly, these simulated colleagues, they're currently powered by the Claude 3.5 Sonnet model. The researchers found that AI performed best for this kind of interaction role in their initial setup.
So the agent being tested can actually talk to these simulated colleagues.
Yeah.
Like ask questions or collaborate.
That's right. So the AI agent being tested isn't just working alone. It has to navigate this digital office and interact with others. It sounds like a much more realistic test, doesn't it?
Definitely. It adds that whole communication layer, which is, let's face it, a huge part of most jobs. So what kinds of actual work tasks are these AI agents being asked to do within this simulated company?
Well, the tasks are designed to be very similar to real professional activities. Each task starts with a task intent, which is basically just a plain English description of what needs to get done.
Yeah.
Then, crucially, each task is broken down into checkpoints.
Checkpoints. Like milestones.
Exactly, like intermediate goals or milestones. And each checkpoint has a point value associated with it, so they can track how much progress the agent actually makes along the way.
Ah, okay. So you can see if it gets stuck halfway.
Precisely. A checkpoint might be something like successfully updating a task in the project management system, or maybe ensuring the accuracy of some data it pulled, or even effectively communicating something to a simulated colleague.
So it's not just a simple did it finish or not at the very end. They're measuring the steps along the way. That seems much more informative.
Exactly. And to figure out if these checkpoints have been successfully completed, they use evaluators.
Evaluators. How do those work?
Often they're automated. Like Python programs that check the state of the simulated environment. Did the file get uploaded? Was the code committed? That kind of thing.
Okay.
But for tasks that are a bit more subjective, maybe like judging the quality of a written report or something.
Yeah, how do you automate that?
Well, they actually use LLM-based evaluation for those. Again, using the Claude 3.5 Sonnet model, the same one powering the colleagues.
Huh. Using an LLM to evaluate the output of another LLM-powered agent. That's meta.
It is a bit, yeah. But it allows them to assess those fuzzier tasks.
That sounds like a pretty thorough way to assess performance. How do they then get an overall sense of how well an agent is doing? What are the main scores or metrics they look at?
They have a few key metrics. The first one is pretty straightforward, the full completion score. It's binary. Either the agent successfully completes all the checkpoints, gets a score of 1.
Or it doesn't, gets a 0.
Right. Simple pass-fail. But, that doesn't tell the whole story. So they also calculate a partial completion score.
Okay, how does that work?
It's a weighted average. It considers the proportion of checkpoints the agent successfully completes, but it also factors in whether it achieved full completion. So an agent that makes, say, 80% progress but doesn't quite finish will still get a decent partial score, definitely higher than one that fails right at the start.
That makes a lot of sense. It rewards both making headway and actually crossing the finish line. Good incentive structure. What about efficiency? Do they look at how long it takes or maybe how much it costs to run these things? Because that's huge in the real world.
Absolutely, that's critical. They track the number of steps, which basically refers to the total number of times the underlying LLM is called upon to generate the next action for the agent.
Okay, so fewer steps is better, generally.
Generally, yes.
Yep.
And they also measure the cost per instance. This is an estimate of the real-world cost of using the LLM's API based on the number of input and output tokens used.
Right, because these API calls aren't free.
Exactly. An AI that can technically do the job it takes forever or costs a fortune.
Yeah, well, that might not be very practical, right?
Not at all. Can you maybe walk us through a specific example, like a task in the TheAgentCompany and how it would actually be evaluated that would really help cement how this whole benchmark works?
Sure. One example they give in the research is the task, manage a sprint for the Rising Wave project. Okay, typical project management task.
Right. The agent needs to do several things here. First, identify any unfinished tasks in their project management system, which is plain in this case.
Okay.
Then notify the people responsible for those unfinished tasks via the internal messaging system, Rocket Chat.
Right. Chase people up. We all know that one.
Then it needs to clone the relevant code repository from GitLab, run a code coverage analysis.
Technical step there.
Yep. And finally, share a report on those findings and maybe incorporate some feedback. So each of these steps has associated checkpoints and points.
So how did the agent do in their example?
Well, in their illustration, the agent successfully finds and updates the sprint issues in plain and notifies the right people on Rocket Chat. So full points for those checkpoints.
Good start.
Then it manages to clone the code repository, but it runs into some kind of issue running the code coverage analysis, maybe an environment problem, who knows? So it gets partial credit for that part.
Okay, hit a snag.
And then it doesn't successfully manage to share the report or handle the feedback part. So 0 points for those final checkpoints.
Stumble at the end.
Right. And the final partial completion score is then calculated based on the points it earned for each of those completed or partially completed checkpoints. Gives you that nuanced view.
Okay, yeah, that gives a really clear picture of how the environment, the tasks, the checkpoints, and the scoring all mesh together. Now, I'm wondering, how did they decide on these specific tasks in the first place? You mentioned they were aiming for realism.
They used a pretty structured approach, actually. They started with the ONET database.
Oh, yeah, the U.S. Department of Labor thing, with all the job descriptions.
That's the one. It's a really comprehensive resource that catalogs different occupations and the tasks associated with them. They focused on job categories that have, a large workforce and generally higher salaries.
Makes sense. Target impactful roles.
Right. And since the TheAgentCompany is a purely digital environment, they had to exclude any roles that primarily involve physical labor. That wasn't feasible to simulate here.
Obviously.
So this naturally led them to focus on roles typically found within a software company. That allowed them to cover a pretty good range of responsibilities, from management and technical work to even administrative and finance functions within that context.
So they're essentially trying to replicate the kinds of things people in, say, a software startup actually spend their time doing day to day.
That's definitely the goal. Within this software company framework, they selected specific tasks by looking at the task lists in ONET, but also by drawing on the real-world experience of the people who created the benchmark.
Ah, so people who have actually done these jobs.
Yeah, many of them have worked in these kinds of roles. And they even used language models themselves to brainstorm potential tasks, which is interesting.
Using the AI to help define the tests for the AI.
Kind of, yeah. They do acknowledge, though, that this benchmark doesn't cover every single task someone in these roles might perform. But it aims to provide a diverse set of representative tasks with clear objectives.
It sounds like a huge amount of work just went into setting up these individual tasks.
Yeah.
How did they make sure the benchmark was actually, reliable and reflected real-world challenges appropriately?
Oh, the process of manually creating and refining these tasks was incredibly intensive. That's very clear from the paper. For each one, they had to define the exact task intent, identify those key checkpoints we talked about,
Right.
and then figure out how to automatically evaluate whether those checkpoints were actually met. They also had to make sure all the necessary data like files, user accounts, project info existed within the simulated company's intranet.
So setting up the whole context for each task.
Exactly. They often had to write specific scripts just to set up the initial state for each task instance. And a really crucial part was building those evaluators, the programs that automatically check for task completion or checkpoint completion.
That sounds complex, especially getting them right.
Definitely.
Yep.
The researchers mentioned it took a team of 20 people, including computer science students, experienced software engineers, and project managers, about 2 months to build this whole thing, totaling roughly 3,000 person hours.
Wow. 3,000 hours. That's a serious investment.
It really is. And they note that some of the more complex tasks took over 10 hours each just to design, implement, test, and verify.
10 hours per task. That gives you a sense of the complexity. What kind of quality control did they have in place then to make sure all that effort resulted in a sound benchmark?
They had several important quality checks, which is good to see. For every single task, they required screenshot proof that the automated evaluator worked correctly.
Okay, visual evidence.
And proof that it was actually possible for an agent to achieve a perfect score if it completed all the steps successfully. You don't want impossible tasks.
No, definitely not.
They also encouraged the contributors who built the tasks to write unit tests for their evaluators, which is standard good practice. Every task that was added to the benchmark went through a code review by the lead researchers, and finally, they conducted a manual double check of absolutely everything.
Everything.
Yeah, the data within the environment, how the evaluators behaved, the point values assigned to each checkpoint. They wanted to ensure consistency across all the different tasks. They even had someone who wasn't involved in creating a specific task review the checkpoint scoring, just to make sure the point values kind of reflected the relative importance or difficulty of each step.
That level of rigor is really essential if this benchmark is going to be trustworthy and useful for the community.
Mm-hmm.
Okay, so they had this incredibly detailed simulated company, all these carefully curated tasks. What kind of AI agent did they use as like the baseline, the first one they put through its paces?
They used an agent called the OpenHands Codact agent, with browsing as their main baseline for the evaluation. The research paper actually includes a diagram, figure 3, that shows its architecture.
Okay.
Essentially, this agent is designed to interact with that simulated environment we discussed through a few key interfaces. So, a bash command line interface for running system commands.
Standard Linux shell.
Right. A Jupyter IPython server for executing Python code snippets interactively.
Useful for data tasks and scripting.
Exactly. And a Chromium web browser, which is based on the Playwright automation library, using action primitives from another framework called BrowserGym.
Okay, so this AI agent can basically act like a person sitting at a computer within this simulated company, typing commands, running code, clicking around in a browser.
That's pretty much the idea, yeah. It has a defined set of core actions it can take. Things like running Python code in that Jupyter cell, executing bash commands in the terminal, and interacting with web pages, navigating, clicking on elements, typing into forms, that kind of thing.
And how does it know what's going on? What feedback does it get?
It receives feedback from the environment in the form of observations. These include the results of its commands, like the output of a script, the raw HTML content of web pages, the structure of the page, even screenshots of what's on the screen at that moment.
Lots of input.
Yeah. And the basic workflow is a large language model takes in the history of everything that's happened so far in the task, plus the current observation from the environment, and then it decides what action the agent should take next. It generates the command or the browser action.
Okay, so the LLM is the brain deciding the next move. based on the situation.
Yeah.
And they didn't just test this one specific agent setup, right?
Yeah.
I think you mentioned they looked at different underlying language models.
Exactly. That's crucial for understanding the landscape. To get a broader picture of current AI capabilities for these work-like tasks, they evaluated several popular language models using the same OpenHands agent framework.
Which ones did they look at?
Both closed, proprietary models and open-weight ones. There are Table 3 in the paper lists models like various versions of Claude, Gemini, GPT-4o, something called Amazon Nova, and also open-weight models like Llama and Quinn.
A good mix.
Yeah, covering the main players. It's important to remember, though, that for the automated evaluators and for those simulated colleagues, the NPCs.
Right, the ones powered by Zootopia.
For those, they consistently use the Claude 3.5 Sonnet model. They mentioned they found it to be the most reliable for those specific supporting roles during their initial testing.
Okay, good to know the setup details. So we've got the benchmark, the tasks, a range of top AI agents being put to the test within this simulated company. Let's get to the results. What were the main findings? What did they actually discover about how well these agents can perform real work tasks?
Right, the moment of truth. The overall performance results, which are laid out really clearly in their Table 3, are quite revealing, I think.
How so?
Well, the Claude 3.5 Sonnet model, the same one used for the NTCs, and some evaluations achieved the highest rate of fully completed tasks. That was 24.0%.
24%. So roughly 1 out of every 4 tasks it could complete fully.
Exactly. And it also had the highest partial completion score, that weighted measure, at 34.4%. So clearly the top performer in terms of raw capability in their tests.
Sense a butt coming.
But yeah, there's always a trade-off. The researchers point out that this top performance came at a cost. It had the highest average number of steps taken per task, meaning it was generally slower or took more actions.
Okay.
And it also had the highest estimated cost per task based on those API token calculations.
So the best performer was also the slowest and most expensive. That really highlights the current limitations, doesn't it? Even the top model struggled significantly.
Yeah.
How did the other models stack up then?
Well, the Gemini 2.0 Flash model was generally second in terms of overall capability, getting close to Claude on some metrics. But interestingly, it tended to take significantly more steps to achieve its results.
More steps than even Claude.
Yeah. Its estimated cost, however, was much lower than Claude's. The researchers kind of hypothesized that maybe this was due to instances where the agent got stuck in unproductive loops, or perhaps explored the environment in a less focused way, racking up steps, but maybe not always expensive tokens.
Okay. What about GPT-4o? That's usually considered a top contender.
GPT-4o had a lower overall success rate compared to both Claude 3.5 Sonnet and Gemini Flash in these tests, but it achieved its results in fewer steps and at a lower cost than Claude.
So faster and cheaper, but less likely to succeed overall. Another trade-off.
Exactly. And among the open-weight models, the largest Llama 3 model, the 405 billion parameter one.
The big one.
Yeah, that performed the best out of the open models. It got relatively close to GPT-4's results, which is impressive for an open model, but it did come at a higher cost than GPT-4o.
It sounds like there's this real balancing act between how capable an AI is, how fast it works, and how much it costs to run. No single winner across all dimensions yet.
Definitely not. It really depends on what you prioritize for a given application.
The paper also mentioned something interesting about a smaller version of the Llama model doing surprisingly well.
Yes, that was quite notable. The Llama 3 model, with 70 billion parameters, so much smaller than the 405B one, achieved a level of success that was quite comparable to its giant sibling.
Really? Comparable results from a much smaller model.
Yeah, and crucially, at a significantly lower cost. This is actually a really encouraging sign for the field.
How so?
It suggests that, we might be able to develop more efficient LLMs that can still perform these complex tasks without needing absolutely massive computational resources. It points towards progress in finding more efficient architectures or maybe better training methods, getting more bang for your buck, essentially.
That's definitely good news for making these technologies more accessible. Okay, so beyond the general performance scores, did the researchers dig into where the agents were succeeding or failing? How did they perform on different parts of the agent company's simulated environment? GitLab versus Rocket Chat, for instance.
They did, yeah. Their Table 4 and Figure 4a break down the performance across these different platforms or tools within the simulation.
And what did that show? Any patterns?
A pretty clear pattern emerged. They found that most of the models struggled particularly with Rocket Chat.
The chat platform.
Right, where the social interactions with simulated colleagues take place. And they also struggled significantly with OwnCloud, which is the simulated online office suite for file management.
Okay, so communication and dealing with a complex web app were tough spots. Why do they think that is?
Well, the lower success rate on Rocket Chat likely points to the fact that current LLMs, despite all the progress, still have quite a ways to go in terms of their ability to effectively communicate, understand social cues, and collaborate in a back-and-forth manner.
Makes sense. Conversation is hard.
It really is, especially context-rich work conversations.
Yeah.
And the challenges with OwnCloud, which apparently has a fairly complex web-based interface in the simulation that suggests that navigating and interacting reliably with real-world complex websites remains a significant hurdle for current AI agents and their browsing capabilities.
Yeah, I could see that. Interacting with people, even simulated ones, and dealing with the often unintuitive design of many web applications. Those are things that humans often find challenging too, so it's maybe not surprising AI struggles there.
Yeah.
What about the different types of work tasks they were given? Were some categories inherently more difficult for the AI agents than others, like coding versus admin?
Yes, absolutely. Their Table 5 and Figure 4b analyzed the performance across different task categories. They grouped tasks into things like data science, administrative tasks, finance, software engineering, and so on.
And the results there?
They found that the data science, administrative, and finance tasks generally had the lowest success rates, even for the most capable models like Claude 3.5 Sonnet.
Okay. So those were the toughest categories. What about the others?
Interestingly, software engineering tasks actually had relatively higher success rates compared to those other categories.
Wait, really? Software engineering tasks were easier for the AI than admin or finance? You might intuitively expect the coding stuff to be among the hardest.
It does seem a bit counterintuitive at first glance, yeah. But their hypothesis makes some sense.
What is it?
They suggest that the current development trajectory of large language models has been heavily focused on and trained on software engineering capabilities.
Because there's so much code available online.
Exactly. There's just vast amounts of publicly available code on places like GitHub, plus numerous benchmarks specifically focused on coding tasks. So the models are arguably better trained for that domain.
Okay.
On the other hand, administrative and financial tasks often involve handling more private or sensitive data, which isn't readily available for training.
Right. Less public data.
Plus, these tasks might require a deeper understanding of specific document formats, complex business processes, or involve navigating intricate, perhaps proprietary software UIs where, again, there's less public training data available.
So the strengths of current AI might be somewhat aligned with the areas where they've simply had the most relevant training exposure. That makes sense. The research also highlighted some common ways in which the AI agents tended to fail. What were some of the recurring patterns they observed? The failure modes.
Yeah, they identified several really interesting failure modes, which tell you a lot about the current gaps. One was just a basic lack of common sense reasoning.
Like what? Give me an example.
Okay, so there was an instance where an agent failed because it didn't infer that a file ending in .docs was a Microsoft Word document. It just treated it as plain text and couldn't process it correctly.
Oh, wow. Yeah, that's pretty basic context humans get instantly.
Exactly. Another recurring issue was a deficiency in, well, social skills or interaction protocols.
How did that manifest?
Like an agent being instructed to introduce itself to a specific colleague on Rocket Chat. It might send an initial message, but then fail to follow through on the conversation, maybe not respond to a reply, and just prematurely consider the task complete.
Dropping the ball mid-conversation.
Right. Difficulties with web browsing were also a frequent problem. Agents would get tripped up by things like pop-up windows, the download our mobile app kind of thing on OwnCloud.
Oh, those are annoying even for humans.
Tell me about it. Or they'd struggle with multi-step processes that seem simple to us, like properly navigating through several screens to download a file.
Okay, so browsing fragility. Any others?
One particularly illustrative category they called deceiving oneself.
Deceiving oneself. What does that mean for an AI?
It sounds odd, but here's an example. An agent was tasked with finding and messaging a specific user, let's say Chenjinye, on Rocket Chat. It couldn't find that exact user. So what did it do? It found a different user and simply renamed that user in its internal representation or its plan to Chen Xinyi and proceeded as if it found the right person.
Whoa. That's not solving the problem. That's like hallucinating a solution.
Kind of, yeah. It's like papering over the gap in its ability rather than recognizing the failure and trying a different approach. It highlights limitations in error handling and perhaps reasoning about identity.
Those examples really paint a vivid picture of the current limitations. It's clear that while these AI agents can perform certain steps or tasks, they still lack a lot of the implicit understanding, common sense, and social intelligence that humans bring almost unconsciously to workplace situations.
Absolutely.
So, stepping back, what are the main takeaways from this deep dive into the Agent Company benchmark? What are the key implications of these findings for, the future of work and AI?
I think the central implication, the big headline, is that while AI agents are showing real progress, and they can definitely handle some of the more straightforward procedural tasks we do at work, they are still quite a distance away from being able to autonomously perform the majority of human work, even within this simplified, simulated setting.
Still a long way to go for full automation of most professional jobs.
Yes, and the types of tasks that proved most challenging really highlight where the gaps are. Tasks needing nuanced social interaction, tasks requiring navigation of complex professional software interfaces, and tasks relying on knowledge or data that isn't widely available in public training sets. These are the areas where further research and development are most critical.
But the researchers aren't just saying it's not ready yet, right? They're also optimistic about the progress that's being made.
Oh, absolutely. They definitely highlight the significant advancements being made, both in the raw capabilities and, importantly, the efficiency of newer LLMs. They point to models like Gemini 2.0 Flash and those more efficient, smaller Llama models as positive examples of this trend.
So progress is happening. The trajectory is upward.
It seems so. They also, quite rightly, acknowledge that the Agent Company benchmark itself has limitations. It's a first version, really.
Like what limitations?
For instance, it naturally focuses on relatively well-defined tasks, partly because those are easier to evaluate automatically. Real-world tasks can be much fuzzier.
True.
They also primarily use that one baseline agent, OpenHands, for the initial evaluations. Different agent architectures might perform differently. And crucially, it doesn't include a direct comparison to how humans perform on these exact same tasks within the simulation.
That would be a really interesting comparison point.
It would. And of course, there's always a potential for some bias in the way the tasks were selected or created, maybe reflecting the specific experiences of the researchers who built it.
All fair points. Do they suggest ways to improve or build on this benchmark in the future?
Yes. They lay out several future directions. They talk about expanding the types of tasks to cover other industries beyond software, maybe even finding ways to incorporate aspects of physically demanding roles, though that's much harder.
Right.
They also want to include tasks with more ambiguous goals, less defined, intense, and maybe longer-term, more complex objectives. Think like the entire process of taking a product from initial concept all the way to execution.
Much more complex, multi-stage projects.
Exactly. And they really emphasize that the Agent Company is open source. They're encouraging the wider research community to jump in, use it, contribute new tasks, new environments, new agents, and help it evolve.
That's great. Community involvement is key for benchmarks like this. So wrapping up then, it sounds like while we're definitely not at the point where AI is ready to take over all our jobs tomorrow,
Definitely not.
this benchmark provides a really valuable, much-needed snapshot of where AI agents currently stand when it comes to tackling real-world work simulation. It's grounding the hype in some data.
Exactly. The Agent Company gives us a much more nuanced picture than you often get from headlines. It shows that, yes, AI can indeed handle a portion of workplace tasks autonomously, particularly the more structured ones. But a significant number, especially those that require more complex reasoning, interaction with others, common sense, and a deeper understanding of the world, remain well beyond their current capabilities.
It really emphasizes the need for continued, focused research to overcome these identified weaknesses, particularly in those tricky areas like social interaction and navigating complexity.
Precisely. There's still a lot of work to be done.
Well, this has been a truly insightful look into the current capabilities and limitations of AI agents in a simulated professional environment. It really makes you think, doesn't it, about which kinds of tasks might be automated sooner rather than later, and perhaps more importantly, what skills will remain uniquely human, or at least human-centric, in the evolving workplace.
It certainly does. It encourages a more critical and informed perspective on the ongoing developments in this incredibly fast-moving field.
Absolutely. And if you, listening, would like to dive even deeper into this research, you can find more details about the Agent Company benchmark on their website and explore the code and tasks on their GitHub repository. We'll be sure to include links in the show notes for this deep dive.
Definitely worth checking out if you're interested in the nitty-gritty.
Thanks so much for breaking that down for us today.
My pleasure. It was a fascinating study to discuss.